As night falls and the sky clears, a soft, glowing band stretches across the heavens like a ribbon of light. This is the Milky Way, the vast galactic home to hundreds of billions of stars, including our very own sun. But behind that breathtaking view lies a deeper question. Just how immense is the Milky Way? What structures lie within it? How does it move? And where exactly do we, tiny human beings, fit in this cosmic expanse? The Milky Way is not just a spectacular sight in the night sky. It is a giant spiral galaxy containing more than 200 to 400 billion stars, countless planets, and layers of cosmic mystery that scientists are still striving to unravel. In this video, we'll take a journey through the grand structure of the Milky Way, from its radiant spiral arms to its enigmatic galactic center, home to a supermassive black hole and beyond, into the realm of invisible dark matter and the possible fate of the entire universe. Prepare yourself for a journey beyond imagination, where we'll not only explore the Milky Way, but also uncover the true place of humanity within this vast and awe-inspiring cosmos. The Milky Way is a barred spiral galaxy, one of the most common galaxy types in the universe. If viewed from above, it resembles a massive flat disk with swirling spiral arms wrapped around a dense central bulge. Astronomers estimate the Milky Way's diameter to be around 100,000 to 120,000 light-years, with its central thickness reaching up to 10,000 light-years. These are staggering dimensions, especially when compared to our tiny solar system, located about 26,000 light-years from the galactic center, just a speck in the vast stellar ocean. The Milky Way rotates around its center, but not as a solid body. Each star moves on its own orbit, influenced by gravity and the presence of dark matter. A full galactic rotation takes between 225 and 250 million years, meaning that since dinosaurs first roamed the Earth, our sun has completed only one orbit around the galaxy. The galactic center is shrouded in thick interstellar dust, making it invisible to the naked eye or optical telescopes. But through infrared, radio, and X-ray observations, astronomers have discovered a powerful secret. A supermassive black hole known as Sagittarius R lies at the heart of our galaxy, with a mass of over 4 million suns. This black hole is not just a gravitational anchor preventing the galaxy from flying apart, it's a gateway to understanding the formation and evolution of galaxies, and a window into some of the most extreme physical conditions in the known universe. If we imagine the Milky Way as a vast cosmic city, then its countless inhabitants are the hundreds of billions of stars, each moving along its own path. Our sun and the entire solar system is just one tiny resident among them, drifting quietly within a small region called the Orion Arm. The Orion Arm is a minor spiral branch located between two of the Milky Way's major arms, the Sagittarius Arm and the Perseus Arm. While not as prominent, the Orion Arm is rich in stellar nurseries, clusters of young stars, and vibrant nebulae, making it a bustling and colorful region full of emerging life. The Sun currently sits about 26,000 light-years from the galactic center, orbiting it at a speed of approximately 828,000 kilometers. While that speed is incredible, the distances involved are so vast that it takes the solar system around 225 to 250 million years to complete a single orbit around the Milky Way. This period is known as a galactic year, and in the Sun's 4.6 billion year lifetime, it has completed only about 20 orbits. That's a modest number compared to the Milky Way's age, which is estimated at over 13 billion years. These long galactic journeys are not just motions through space, they represent the evolution of life, cosmic history, and mysteries yet to be uncovered. From the humble location of our solar system within the Orion Arm, we can begin to visualize the overall structure of the Milky Way, a vast system divided into key components, each playing a vital role in the galaxy's formation and evolution. The first is the galactic disk, a thin, flat region that houses most of the stars, dust, and gas. This is where most star formation occurs
making it the liveliest and youngest part of the galaxy. The spiral arms wind outward from the center, brimming with star clusters, nebulae, and the explosive remnants of supernova. Next is the galactic bulge, a dense ellipsoidal or bar-shaped core at the very heart of the galaxy. This region is packed with older stars following chaotic orbits, many of them over 10 billion years old. It also contains the highest concentration of stars in the Milky Way, and it's here that we find Sagittarius A, the supermassive black hole silently anchoring the galaxy's center. Surrounding the disk is the galactic halo, an enormous, nearly invisible sphere that envelopes the galaxy. It contains ancient globular clusters and vast amounts of dark matter that cannot be directly observed. Though rarely shown in popular images, the halo plays a crucial role in keeping the Milky Way gravitationally stable thanks to its invisible pull. Together, from disk to halo, these components are bound by gravity and the unseen force of dark matter. Each part is not just a physical layer, but also a chapter in the cosmic history of how galaxies like ours come to be, and humanity is just beginning to decode the first pages. The Milky Way does not exist in isolation. Like all galaxies, it is the product of a long and complex process of formation and mergers, unfolding over billions of years. Scientists believe the Milky Way began as a small protogalaxy formed from primordial gas clouds after the Big Bang, gradually growing by accreting matter and merging with smaller galaxies. By studying ancient globular clusters and the unusual motions of stars in the galactic halo, astronomers have found strong evidence of past collisions and mergers. Even today, the Milky Way continues to consume smaller galaxies, such as the Sagittarius dwarf galaxy, which is currently being stretched and assimilated into our galaxy. This process of merging doesn't destroy the galaxy, rather, it's a vital mechanism that drives galactic growth, increases mass, reshapes its structure, and even triggers new waves of star formation. In many ways, the Milky Way is a living history of cosmic collisions, written across the positions and movements of the stars we observe today. One of the reasons the Milky Way has remained stable over billions of years is thanks to something nearly invisible: dark matter. Although we cannot observe dark matter directly, it emits no light, does not absorb or reflect any radiation, scientists are confident it must exist. The proof lies in the way stars orbit within galaxies. Their motions simply cannot be explained by visible matter alone. If we only accounted for the gravity of stars and dust, the outer arms of the galaxy would rotate much more slowly. Yet, in reality, they move much faster than expected, while the galaxy remains gravitationally intact. This reveals that the Milky Way is surrounded by an invisible halo, the dark matter halo, which may constitute up to 85% of the galaxy's total mass. Dark matter is the key to understanding why galaxies don't tear themselves apart at high rotation speeds. It's also a fundamental ingredient in shaping the universe's large-scale structure, from individual galaxies to galaxy clusters and the vast cosmic web. At the heart of the Milky Way, hidden beneath thick clouds of interstellar dust, lies one of the most mysterious and fascinating objects in modern physics, the supermassive black hole Sagittarius A. This black hole cannot be seen directly through visible light or optical telescopes, but its existence has been confirmed by tracking the unusual motion of stars near the galactic center. Some stars orbit an invisible point at extreme speeds, something only possible if an incredibly massive and dense object exists there. Measurements reveal that Sagittarius A contains over 4 million times the mass of our Sun, compressed into a region smaller than our solar system. At such density, not even light can escape once it crosses the event horizon. Strangely enough, despite its immense power, Sagittarius A is currently relatively quiet. However, in the past, it may have been far more active, swallowing clouds of gas,
emitting powerful X-rays, radio waves, and possibly contributing to the formation of the enormous Fermi bubbles that stretch tens of thousands of light years above and below the galactic plane. Beyond the galactic center, the Milky Way is also home to stellar factories, enormous cold molecular clouds where new stars are constantly being born. These clouds, composed mainly of hydrogen and dust, can contain thousands of solar masses of material. When a region within such a cloud becomes dense and cold enough, gravity causes it to collapse inward, forming dense stellar cores. These cores continue to contract, heat up, and eventually ignite nuclear fusion, the birth of a new star. Famous star-forming regions include the Orion Nebula, the Cygnus X region, and the Carina Nebula, where we can observe hundreds of brilliant young stars in various stages of formation. These regions are not only visually stunning, but also provide key insights into how the universe continues to evolve. The ongoing birth of stars is clear evidence that the galaxy is still very much alive and active. The life and death cycle of stars forms the heartbeat of the galaxy, a continuous process that has shaped the cosmos for billions of years.
Alongside newborn stars, the Milky Way also hosts some of the oldest known stellar populations in the universe, the globular clusters. These are dense, spherical groupings of hundreds of thousands of ancient stars held tightly together by gravity and distributed throughout the galactic halo. Globular clusters can be 12 to 13 billion years old, nearly as old as the universe itself. They are not just relics. They are cosmic time capsules that offer scientists clues about the Milky Way's earliest days. Famous globular clusters like Omega Centauri, M13 in the Hercules constellation, and M5 are favorite targets for skywatchers. Despite their vast distance from Earth, their light remains brilliant due to their dense stellar populations. These shining jewels, suspended for eons in the cosmic void, are reminders that the universe still holds living memories from the dawn of time. In the Milky Way, not all stars live forever. Depending on their initial mass, stars follow very different life cycles, from their birth in nebulae to their final moments in explosive brilliance or quiet extinction. Stars like our Sun, with medium mass, shine steadily for billions of years before swelling into red giants, gently shedding their outer layers and leaving behind white dwarfs, dense, faint stellar remnants that slowly cool over time. In contrast, massive stars many times heavier than the Sun face a more dramatic fate. When they exhaust their fuel, their cores collapse, triggering a supernova explosion, a cataclysm so powerful it can briefly outshine an entire galaxy. What remains may become a rapidly spinning neutron star, or in extreme cases, a black hole, the ultimate product of gravitational collapse. But such stellar deaths are not in vain. They seed the cosmos with heavy elements like gold, silver, and uranium, the building blocks of planets, and even life itself. Beyond stars, our galaxy is home to billions of planets, potentially more than the number of stars, when you include those orbiting dim stars, binary systems, or even rogue planets drifting alone through space. The existence of exoplanets, planets beyond our solar system, has only been confirmed in recent decades. Thanks to telescopes like Kepler, TESS, and now James Webb, thousands of new worlds have been discovered, spanning a vast range of sizes, compositions, and orbital distances. Some lie within the habitable zone, where liquid water could exist, making them promising candidates for extraterrestrial life. In fact, scientists estimate there may be hundreds of millions of potentially Earth-like planets in the Milky Way alone. The big question remains, are we alone? If life exists elsewhere, it may be radically different, in biology, chemistry, or even consciousness. But the search for life is more than science. It's a journey to understand our place in the grand cosmos. The Milky Way is not alone. It's part of a larger community known as the Local Group, which includes over 80 galaxies. Among them, The most prominent are the Andromeda Galaxy and the Triangulum Galaxy. Though millions of light-years away, these galaxies still interact gravitationally. In fact, the Milky Way and Andromeda are currently on a collision course, predicted to merge in about 4 billion years. But this won't be an explosive Hollywood-style crash. Because the distance between stars is so vast, most stars will pass by each other harmlessly. Instead, the galaxies will merge slowly, forming a new supergalaxy, possibly named Milky Way. This merger will reshape the galactic structure, redistribute stars, and may even reignite central black holes. Whether or not humanity survives to witness it, this will be a cosmic inevitability. Two galactic titans destined to collide in the dance of gravity and time. In the universe, nothing stays still, and the Milky Way is no exception. Our galaxy is moving through space at about 600 kilometers per second relative to the cosmic background. While the solar system orbits the galactic center, the entire Milky Way is being pulled toward a mysterious region known as the Great Attractor, a massive gravitational anomaly located about 250 million light-years away. This movement reveals that the universe isn't just expanding. It also has a complex structure with gravitational flows between galaxy clusters and superclusters. The Milky Way, along with the local group, belongs to a supercluster called Laniakea, which means immense heaven in Hawaiian. This idea helps us grasp that our galaxy is just a small eddy in the vast cosmic ocean, swept along by gravitational currents on a scale we are only beginning to understand. The very existence of the Milky Way reminds us that the universe is a dynamic and ever-changing system. Nothing lasts forever, not even galaxies. Current cosmological models suggest that, in the far future, star formation will gradually slow as gas reserves are depleted. Once the last stars fade, the galaxy will enter a dark era, filled only with white dwarfs, neutron stars, and cold black holes. If the universe continues expanding indefinitely, the Milky Way will become increasingly isolated, and light from other galaxies will no longer reach us. While it may merge with Andromeda, over time it will become a lonely, dark island adrift in a cold and silent cosmos. Though this scenario lies trillions of years ahead, it teaches us that everything has a beginning and an end, even the grandest galaxies. That's why this moment, where life exists, is more precious than we often realize. In our journey to understand the Milky Way, perhaps the most astonishing thing isn't black holes, supernovae, or billions of stars. It's the emergence of human beings with the consciousness to look up and ask, "Who am I?" We're not just inhabitants of the galaxy. We are beings capable of understanding it, mapping it, calculating its dynamics, and passing down its story through generations. Though tiny in size, we possess the ability to grasp the infinite. Every time you look up at the night sky, the light you see may have traveled from stars that died millions of years ago. Yet that light connects us to the universe's history, its billions of years of evolution, and the eternal questions of life and existence. And in that moment, as we gaze upward, we realize we are not insignificant. We are a vital part of this vast and magnificent cosmos. As technology continues to advance, humanity's ability to explore the Milky Way grows exponentially. Space missions like Gaia have allowed us to create highly detailed 3D maps of over 1 billion stars, tracking their positions, speeds, and motions with unprecedented precision. These maps aren't just technical marvels. They're living portraits of the galaxy's structure and dynamics, enabling us to trace past galactic collisions, dark matter distribution, and the evolutionary history of the Milky Way since its early days. In addition, next-generation telescopes like James Webb, ALMA, and the upcoming Nancy Grace Roman Space Telescope will allow us to peer deeper into stellar nurseries, alien worlds, and even uncover more about dark matter and dark energy. With every technological leap, the galaxy surrenders a bit more of its mystery, bringing us closer to answering the age-old questions. Where did we come from? Where are we going? One of the most beautiful aspects of astronomy is this: anyone can join the journey of discovery. You don't have to be a professional astronomer, just a small telescope, or even your eyes, is enough to begin. When you gaze at the night sky, you're connecting with billions of years of cosmic history. You're seeing light from stars in the Orion Arm, our sun's home. You're witnessing the Milky Way arching across the sky, the galactic disk viewed from within. And if skies are dark enough, you can even glimpse globular clusters, nebulae, and our galactic neighbors, like the Magellanic Clouds. Today, citizen science projects like Zooniverse invite everyone to help classify stars, identify exoplanets, and contribute directly to real astronomical research. Science is no longer closed off. It is an open door for all to walk through. We are not just observers, we are storytellers of the cosmos. When we bring together all we know about the Milky Way, its structure, history, future, and humanity's role, we realize this isn't just another galaxy among billions. It is, in a very real sense, our home. Every atom in our bodies was forged in the nuclear furnaces of ancient stars, drifting across the galaxy for millions of years before becoming life on Earth. We are products of this galaxy, built from starlight, gas, and cosmic dust. This realization doesn't diminish us. It elevates us. It binds us deeply to the universe. By understanding the galaxy, we also begin to understand ourselves, the origin of life, and the preciousness of every passing moment. The Milky Way isn't just a location in the cosmos. It is the first chapter in the never-ending story of humanity and the universe. The Milky Way is our galaxy, but it's not just something we observe. It is a cosmic stage where some of the most extraordinary events have occurred, are unfolding now, and will continue to shape the future for billions of years. From galactic collisions and the birth and death of stars, to the search for life beyond Earth, nearly everything either begins in, happens within, or is influenced by this galaxy. And within this vast cosmic story, we, humanity, are writing our own unique chapter. One day, perhaps, humans will no longer be confined to the solar system. We may journey among the stars, explore distant worlds, and carry with us the eternal question: is someone else also looking toward the Milky Way right now? The galaxy is more than just a structure. It is a vessel of dreams, imagination, and humanity's deepest yearning to reach beyond.
No matter what fate awaits the Milky Way, collapse, unraveling, or merging with another galaxy, one thing remains certain. This moment, in which life exists and humanity looks to the stars, is a rare and precious miracle in the universe. We may not live long enough to witness the galaxy's end, but we live in a time when the human mind can understand it, simulate it, and share its story with future generations. And that's why every gaze into the night sky, every child who asks about a distant star, and every why whispered into the dark is a spark, a small flame adding to the collective fire of human curiosity. Keep looking up, keep asking questions, and above all, keep dreaming. Where we were born, and where light from stars long dead still reaches us today. If this journey through space sparked wonder in you, share this video with others who might feel the same. And don't forget to subscribe to the channel and hit the bell so you never miss another deep dive into the cosmos. Thank you for watching. Keep looking up and never stop asking questions.